Hello, this is the January Approachable Sudoku for the 13th of March 2024. It is Slow Thermo by Clover, featuring what appear to be regular thermals but are actually slow thermals. So yeah, this is going to be interesting. Normal Sudokus apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits along thermometers must either increase or stay the same, starting from the round bulb. So let's take this thermal for example. Digits may increase, like so, in any order. The digits could also stay the same, so this is also valid for a slow thermal. So something that looks like this is also valid. This is a valid way of putting those digits in. Right, and those are all the rules. With that, let's just begin solving. So, while regular thermals would cause this 9 length thermometer to be a 1 to 9 immediately, that is not the case for slow thermals, because we have this little hitch here which can in fact have repeated digits, so they could both be 2 if they wanted them to be. However, those digits, for example, are all different because they occupy the same row. So even though they are on a thermometer, they are in the row, they are in the same row, which means they all have to be different. And so actually, while those can be the same, those are all different, which actually provides us with quite a lot of restriction. For example, even if this was at least a 1, this is at least a 2, this would be at least a 3, this would be at least a 3 if those two are the same. This would be at least a 4, and we can continue the chain to say that this is now at least an 8. Which is actually the minimum it can be, because it can't be a 9, because of the 9 already in the box. And so we have to take the minimum, giving us all the digits along this thermal. We can also do the same over here, and say that, well, this is at most a 9, so this is at most an 8, this is at most a 7, and we can keep going down the chain. Whoa. Like so. Jeez, I'm so sorry. So this is at most a 2, and because of the 1 already in the column, this must now be a 2 because it can't be anything else, which means we once again have all the digits along this thermal, which is pretty useful. Oh, and now a cool trick in these three roles is something known as roping. Because look at those 3 digits. Where do they go in this box? They can't be there because there is no overlap. They can't be in those digits because they apply in the same column, and therefore those 3 digits have to appear in here somewhere. We can continue by saying, where do those 3 digits go in here? Well, those 3 digits must be here, because they can't be here or here. Those are in the same rows as those digits. We can now do the same with that set of digits, which must be here in this box and therefore here in this box, as well as those 3 digits which must all be the same. So there you are, roping. And now we can do a lot more cool stuff with this. Those 3 digits are in those 3 digits, which, because they're all different, must be in ascending order. This can only be a 1, it can't be anything greater than 1, it can only be the same. In fact, those digits are therefore 2 and 3 to finish this set, and this 3 resolves that. 7, 8, and 9 must appear here, which again must be in increasing order. That digit must not be a 9 because it can't be anything else. Those digits are 7 and 8, which are resolvable by this 7 down here. You could also say that because they must be in increasing order, it must go 7, then 8. The remaining digits here are 4, 5, and 6, which in both of these cases must be in increasing order. So 4, 5, 6, 4, 5, 6. This digit must be either lower than or the same as that, but cannot be 3 or lower, so it must just be 4. That digit, for a similar reason, must be 6, and so the center digit is a 5. And this is starting to become very X windmill-like, although the 9 and the 8 here don't actually follow that pattern. Alright, so this was fun. Let's keep going. This is 1, 8, and 9 to finish the row. 9's here, place a 9 there. 1 here fixes the remaining 1, 8 pair. Those digits are 1, 2, and 9. The 2's here, place a 2 there. The remaining 1, 9 pair is resolvable. And we're done with the middle band, so let's just, I guess we'll keep going. We've got a couple triples to work with. Those triples are 1, 5, and 7, I think. And then those triples have to be 2, 3, 5? Yes. Now this digit and that digit, well, this digit is less than or equal to that, which could be a lot of things if this was a 7. Yeah, in fact, I don't really see much else with this. Do I see anything more? Yeah, actually, do I? Maybe. I can tell you that... Oh, this could be a 7, that's the issue. I was gonna say 7, 8, and 9 have to be here, but no. I know 8 and 9 have to be here, because those digits are always less than or equal to them. So 8 and 9 have to be in here. 8 cannot be in this square because of this 8, so those digits are 8. 9 can't be here, so 9 is one of those cells. I guess what's more useful is this 2 probably, or this cell, because whatever this is at most that digit, and so this is at most a 5. It can't be 3, 4, or 5, or 1, so it must just be a 2, meaning that digit must be a 1. So I suppose 6 now can't be in those cells, 6 must be here, which joins the 9 to form a 6-9 pair. The 8 can only be in that cell, and the 7 must in fact be there, which does do some good for us because that digit must be at least must be at least equal to 7, and because 1 and 5 are not in that category, 7 must just be there. Could probably do the same thing down here, but I guess we'll do a pair over here first. Those digits have to be 1 and 4. And in fact, therefore, this cannot be a 5, because if it was a 5, this is always going to be less than 5, which is not valid. So this must be a 1. That resolves this 1-4 pair, which makes this is valid, this is fine. 6 resolves this 6-9 pair over here. This 1 means that's a 5, I should have seen that coming. Those digits are 2 and 8. Actually, that's resolvable by this 8 over here. And those digits are 3 and 9? Yes. But this can't be 9 because that is never going to be at least equal to 9. So this is not just a 3, which pushes a 9 down here. 3 can't be there. And in fact, oh no, this could be a 3, but it can't be a 2 because 2 is less than 3. Okay. Now what? 1? Yes, 1 in this box must be here. I think that's all the 1s. Yeah, I think it is. All the 9s. Yep, 9 we can do the same thing. That gives us a triple in this box. This has to be 5, 6, and 7. 7 here pushes a 7 into that cell up there. There's a 5, 6 pair here waiting to be resolved, but I don't think it can be. That forms another pair here though. That's 8 and 5? No, 3 and 8, sorry. 8. Here resolves that. So that now can't be a 3. Which pushes a 3 over here, is the only place 3 can go in this column. Those digits are also, I think, 6 and 4 to finish the box, and this 6 resolves that. 6, sorry, not 4, not 2. Those digits form a 2-5 pair, which is sensible. Those digits form 3 and 4, which is resolvable. And I think we're almost done. There is a pair consisting of 4 and 6 again, I think. 4 here resolves that, which proceeds to resolve this, and gives us a single digit here, which has to be, I think, a 2. That resolves all of these 2-5 pairs. And that final digit would therefore be a 7, finishing the puzzle in 13 minutes and 54 seconds. Nice. We have a little surprise roping here. So I enjoyed this one. Yeah, we don't usually see these esoteric rule sets. So I think this was cool. I hope you enjoyed this puzzle as well. I'll see you guys next time. Bye bye.